questionnaire to various persons in different age groups and backgrounds. These questionnaires were distributed to wheelchair users and potential non-wheelchair users.
The body-function deployment technique was used by the team in order to determine which characteristics and features were fundamental to the design of the product. The questionnaire handed out to the general public played an important role here, especially in determining the importance ranking of each customer requirement. This way, the team was able to act on true data, on what customers really want and need. The product design specification document identifies the nature of the problem and the requirements of the product being designed. Alongside further research, the team once again referred to the survey results. This led to a better understanding of the problem, leading to a better overall solution. The team now began to synthesize the solution. Meetings for brainstorming sessions were held, where each member gave his own outlook on relating factors: comfort, motion, performance, and more. The emphasis, though, had to be on aesthetics. Material feel, dynamics, colors, lights, and most importantly shape were all acknowledged during these sessions. Scamper techniques were also used. This gave us the idea of introducing a team option to the customers. Similarly, how customers can easily change covers of the mobile phone to suit their liking, MyWiz is offered with a range of themes, catering for young to elderly users. In the meantime, each group member started to submit their own conceptual sketches. Initially, the sketches differed significantly, each tackling different problem areas, which the designer's standpoint required most action. The group then narrowed their solution down and with the help of their tutors decided to exercise another survey, now using design for emotion techniques. A new sketch was prepared introducing each conceptual design into the real world, and the public's reactions were then judged according to the standard design for emotion techniques. Finally, we decided on the final sketch, emphasizing aesthetics, comfort, and maneuverability.
The function means tree was drawn next, where the functions of the wheelchair were listed and their respective means were pointed out. Then we progressed to our morphological chart, where we listed the number of means for each respective function. Then we selected out the most appropriate mean for our application by basing our decisions with a number of justifications. For our design project, we applied the theory of the maze, where first we applied the functional domain, where this consisted of the various functions that our wheelchair offered. On the other hand, the process domains defined the sequence of operations that our wheelchair performed, and finally the construction domains, where this consisted the various components of the wheelchair.
The main aim of the life-size physical model was to help us as designers to visualize the product in a more holistic manner. Inexpensive materials were used, but nonetheless, the group could better envisage how parts would be eventually divided, saving precious time when coming into the detailed design.
During the 3D CAD modeling, we carried out a number of calculations to ensure both that the wheelchair is mechanically stable and that it is capable of withstanding the weight capacity of a person. Other calculations were also done to calculate the size of the battery and the power required to move the wheelchair, where we considered a number of variables such as the rolling resistance and the air resistance.
A design for X exercise was carried out during the design of our wheelchair. We catered for design for cost, for manufacturing and assembly, for safety, and also for aesthetics and emotions.
In 3D CAD, the members involved started by constructing a frame structure. Bearing in mind design for manufacturing approaches, we opted to use a standard cross-section corresponding to ISO 4019. This would eventually pay off when coming to produce or subcontract production of these beams. In addition to all this, the seat reclines tilting to an angle as preferred by the user. This option's addition was stressed both by the group and by the tutor, especially after understanding the importance of feeling comfortable even after a whole day.
A design failure modes and effect analysis was carried out, in order to analyze the potential problems which could arise from any component found in the wheelchair. This analysis aided us in increasing the quality and reliability of our product.
My wheels changes the way we look and feel about wheelchairs. It's not only about aesthetics though. Simplicity of use and safety also takes My Wheels to a whole new level in Aesthetically.
My Wheels will be available with different themes, color schemes and branding to make your wheelchair with a unique design, matching your personal taste.
My Wheels was designed as a stylish, innovative alternative